Morning, guys. So we have completed all of the introductory material, which was all around um, like what is data, what is information, what types of data you can gather. So we looked at numerical data, we looked at continuous data, how you can gather your data. So do you go with a primary source? Do you go with a secondary source? Do you based on which one of them you pick, you need to write a survey. How do you write a correct survey? If you go down the road of secondary data, how do you choose appropriate secondary data that is reliable, etc., etc. So we went through all that at the start. Then we spent the last couple of weeks going through charts. So I've given you loads of charts to choose from. I am expecting a couple of different ones. I gave you all the Leaving Cert charts and then a couple of the junior cert ones, just to, if you want to use them, that they're available to be used. So the last thing I'm going to do before I leave you off with your actual project is to talk about analysing the data. So we've done a tiny bit of this in that when you did correlation coefficient, that was analysing the data. So it was kind of hard to separate. I didn't want to take it away from the scatter graph, but when you plot a scatter graph, if you get a correlation coefficient, the correlation coefficient is telling you whether or not there's a positive or negative correlation between the two sets of data that you plotted, and as well as there being either a positive or negative correlation, how strong is that correlation? So is it a positive, strong correlation? And if so, what does that mean? So we did questions around interpreting the correlation coefficient in the context of the question. So rather than just saying the correlation coefficient is, 0.96, we say a correlation coefficient of 0.96 means there's a strong positive correlation between the x-axis of this graph and the y-axis of this graph. This means that as the x-axis increases, so too does the y-axis, and then you would add in what is on the x-axis. So you would say, in the context of my data, this means that as the person's height increases, so too does their arm span. Yeah, so that was how we took correlation coefficient and actually interpreted it, like gave it context, as opposed to just being a random number. So we're going to kind of continue that on and do more analysing of the data. So this is where you've gathered the data, whether it be primary or secondary source, you've charted it, you've chosen the appropriate charts, you've drawn the graphs or the bar charts or the stem and leaves or the pie charts or whatever the hell you've chosen. And now we're going to actually interpret that data. We're going to go into some analysis and decide, it's just to basically give you something to talk about with regard to the data rather than just saying, right, there's my data, analyse it yourself. Okay? So when you're analysing data, obviously, if it's specifically a scatter plot, you have the correlation coefficient option. But for all data, you can get what's called a measure of central tendency. And a measure of central tendency is just a fancy way of saying average. Okay? So there are 3 different averages that you have to be able to calculate, and we did all 3 at junior cert, so it shouldn't be that, it should be a revision as opposed to being brand new. So the first of the averages that you need to be able to calculate is the mean. The mean is where you add up, so you add up all the data and you divide by the number of data points. Oh. I'm just going to shut this down for a second. Oh, there you go. Okay, so you add up all the data and you divide by the number of data points. So, just a couple of points about the mean. It's very accurate. Because it uses all the data. As I said, you add them all up and divide by the number of data points. So it's really, really accurate way of calculating an average, but it's not always appropriate. So the mean is only appropriate if you have no outliers. If there are outliers in the data, so by outliers I mean extreme values, so really big or really small. If you have any outliers in the data, because all of the data is included, when you include this really, really big number or this really, really small number, it's going to affect your overall mean. So if it's a big number, it's going to make your mean look kind of disproportionately big. And if it's a really small number, it's going to make your mean look quite small. And it's not a fair reflection on all of the data. Like, it's a little bit like if you went through all of the year getting like 80% plus in a maths exam, and then you came in one day and you, like, I don't know, had a migraine or something, and you basically had to keep your head on the table and you attempted a few questions and you came out with like 22% or something like that. It would be really, really unfair of me to include that 22% as part of your average grade, because it is a massive outlier. It's an extreme value. It doesn't fit in with everything else. So the mean is not appropriate if there are outliers in the data, because it is heavily affected by an outlier. Is that okay? So that is, you have to be able to look at your data and decide an appropriate average. So it's not good enough to just calculate an average. It has to be an appropriate average. And the mean isn't always appropriate. Okay, I think it kind of seems like it is, because it's the go-to. You know, you probably, if I asked you to calculate an average, most of you would go ahead and do a mean, but it does have limitations. Okay, the second one then is the mode. So MO for mode, MO for most. The mode is the most frequent number to appear in your data. So the mode is the only one that can be used for categorical data. So that's kind of its big use. It can be used for numerical data, but mean and median cannot be used for categorical data, so it's the only one that can be used for categorical data. So that's kind of its big plus point. It does have a few drawbacks. Sometimes it doesn't exist. As in order to have a mode, you have to have one number or colour category, whatever, that appears more than all the others. Sometimes that just doesn't happen. Like, you have a set of data and you've got 2 2s, 2 3s, and 2 6s. So there is no mode, because not one of them kind of stands out as the one that appears the most frequent. So sometimes it genuinely just doesn't exist within the data. And the other thing, which is probably more happens more often, is that it's not appropriate. So it's supposed to be an average. It's supposed to make sense. Sometimes it just doesn't. Like, for example, if you were looking for the average number of letters delivered by the postman to a set of houses in a given day, and you want, so that was what you were tasked with, find the average number of letters delivered, right? And let's say there's 10 houses, and 7 of the houses get no post that day. And then the 8th house gets 5 letters, the 9th house gets 10 letters, and the 10th house gets 2 letters, something like that. If you were to use mode as your average, you would get 0, because 7 houses got no letters. But 0 is not an appropriate average for that example, because there were some houses that got quite a bit of post. So it just wouldn't be appropriate to choose 0, to choose the mode and as a result 0 in that example. So the mode is definitely limited. Easy to calculate though. And the last one, I am going through these quite quickly, but like I said, you've done them before, so hopefully that you remember some of them. The median is the middle number once the numbers have been ranked. Okay, so it's the middle number, but you first of all have to put the numbers in numerical order, smallest to biggest. Once the numbers are ranked, then you can take out the smallest one. The middle number, the median would be, in terms of like kind of pros and cons for it, it's not a better average than the mean unless there's an outlier. Okay, so the median is used instead of the mean when there's an outlier in the data. Okay, it is a good measure of center, it's a good average, but it's not better than the mean unless there's an outlier, and then it is better than the mean. Okay, so you need to know how to do all three. You need to know how to actually calculate all three. But the stuff I'm talking about and having the blue writing here is quite, I'm not going to say equally as important, but it is very important as well. There's no point in you gathering whatever data you're going to gather for your project and then realizing that, or me realizing that you've presented this beautiful analysis of the data and you've calculated a mean, but you've got massive outliers in the data and your mean is essentially worthless. So be careful, okay? So here we have a golfer keeping a record of his score in competitions during 2016. So he got 75, he got a score of 75 4 times, he got a score of 76 3 times, he got a score of 77 4 times, 78 7 times, 79 twice. Okay, so I mean, you can do this if you want to. I'm going to show you slightly quicker ways to do all of these. But essentially what we have here is 75 4 times, 76 3 times, 1, 2, 3, 4 77s. It is going to catch up now. 78 7 times. So that's 1, 2, 3, 4, 5, 6, 7. So 78 7 times, and then 2 79s. Just going to see if I can speed it up by shutting it down. There you go. Okay, so there's my full list. So to get the mean score, we can just add all of them up, or we can recognize the fact that there are 4 75s, there are 3 76s, there are 4 77s, there are 7 78s, and there are 2 79s, and we can kind of simplify the maths a little bit. So I'm just going to do each one. Now, like I said, you can just add, like, expand them out the way I did and just add them all up. But, like, you know that if there's 4 75s, you can do 75 plus 75 plus 75 plus 75. You can use addition, or you can use multiplication. 4 times 75, and it's just a bit quicker that way. 5, 4, 6. So I am doing all the multiplications just so we can see whenever it catches up. Oh my goodness, it's just very slow. Okay, so that's where I'm up to. So I did it by multiplication rather than addition. Obviously then once I got all my 475s, my 376s, I added them all up and I got 1540, so hopefully that's correct. Then in terms of because the mean is add them all up and divide by the number of numbers. So you can see from this list here, if you just count them up, that's how many numbers there are. Alternatively, you can just add up the frequencies. So if you just add up the frequencies, that will tell you how many numbers there are, because the frequencies tell you how many numbers there are. Like there's 475s, there's 376s. So if I just do 4 plus 3 plus 4 plus 7 plus 2, I'm getting a total of 20. So 1540 divided by 20 gives me a mean of 77. Okay, part 2 is the mode. So the mode should be really easy. It's the one that appears the most often, and you can tell when it's done in a table like this, you can tell really easily from the frequency which one appears the most often. So it's the 78 because it appears 7 times and nothing else does. Okay, so that's the mode done, nice and easy. And then the last one is the median. Okay, so placed in order, like they are above there in green, you get the median by picking out the middle number. So you can cross off the first number with the last, the second with the second last, third last, fourth last, fifth last, sixth last, seventh last, is it keeping up? Eighth last, ninth last. Now, if it presents you with a single middle number, great, but because this is even, it won't. So if you get two numbers like this, I know it's pointless here, but the rule or the method is you add them up and divide by 2. So that gives me a median of 77. Okay, now adding up and dividing by 2 is a little bit pointless there, but it isn't always. Okay, now there is an alternative method to do the median, which I'm just going to show you here. So you do half n, where n, oh sorry, oh yeah, I was right, where n is the number of numbers in the set. Okay, so a bit like when you're doing the mean. Yeah, so there's 20 numbers in this set, so I do half of 20. Sorry, just waiting on it to catch up. And that's 10. Okay, if you get, what would it be called? A natural number, I suppose? Let's call it a whole number. If you get a whole number, the median is this number and the next number. So in this case, we would be looking for the 10th number and the 11th number. Cut up? No. Just wait. So because the median, like when you do that cross-Coyote thing, what you're getting yourself to is the midpoint, like the middle of it. So that's why we half the data, because we're looking for the middle of it. So you half the data, and if it's an even number, so if it's an even number of numbers, when you half it, you'll get a whole number. And if that happens, the median will be that number and the next number. So in this case, it would be the 10th number. Just trying really hard to write. 10th and the 11th number. Okay, so if I go back up to my data whenever this lets me. Okay, so the median should be the 10th and the 11th number. So if I just start popping numbers on these, this is the 1st, the 2nd, the 3rd, the 4th, the 5th, the 6th, the 7th, the 8th, the 9th, the 10th, and the 11th. Okay, so we would take the 10th number and the 11th number, which is 77 and 77, and we would add them up and divide by 2. Okay, it's just an alternate method. Sometimes the cross-out method isn't appropriate because you've got like 100 pieces of data, so you're never going to write them all out. So for that reason, it's handy to have this one. Just as a point to note, if it's not even, so if, for example, there was, 31 pieces of data, for example, so if we do half of 31, that would be 15.5. Okay, so if the number of pieces of data is odd, when you half it, you're going to get a decimal. If that happens, you round up. So we would find the median on the 16th number. That's what you do if it's odd. Is that okay? So that's how you do the mean, the mode, and the median. There's more examples there. I am going to pick out a couple of questions here that I'll put into the homework journal that I'm going to get you to do for the rest of this class. Hopefully then you won't have homework. We'll go through it on Thursday and we're nearly there then. We literally just have to do, so that was averages, we have to do ranges, and then that's it. So I'd say next Monday you're going to be good to go on your project. Okay, so get that finished, get the homework done please. It's in the homework journal. It will also be on Schoology, and I'll mark it on Thursday. Alright, thanks guys.